Good morning, grade 9s. Here is your Chapter 6 tips for graphing. I thought I would just try this app and record some of the information you need to know before you can complete this unit. So we're going to talk about graphing, just some terms that you're familiar with, or if you're not, then here they are. So your x-axis on a graph is always your independent. Okay, so your x-graph is always on your horizontal line of any graph. And such things that are independent, for example, time is independent, pizza toppings compared to cost are independent. So those are things that you want to think of, or speed. Those are some examples of dimensions that could be independent. On your y-axis, I'm just going to slow down my writing here. That is where your dependent variable is. Okay, and dependent means that it will happen because of x. So it's dependent on x. So, for example, certain things, cost of things or money, dependent on x. Distance can be dependent on x in a time-distance graph. So in y-axis is graphed on your vertical line of your graph. So when you bring this together, what does this look like? What are some important things you need to know about a graph? So if I graph, I usually draw my vertical and then my horizontal line. I'll label my axes. So my x in this example could be just my x values, and my y values will be on my vertical. And what am I graphing? Okay, so usually you're given a set of data on a t-chart, or you're given a linear equation that you need to graph in grade 9. So if I have an x and a y, if I have some random values, if x is 1, 2, or 3, and say y is 2, 4, and 6, how would I graph this data? Well, the first thing I need to do is I need to give some numbers or some spacing to my x and y. So I'm going to put some 1, 2, 3. Now you're going to do this on graph paper, and you're going to make these equal distance apart, right? So you want nice equal spacing, okay, between the numbers. So if you look at my numbers, it goes up by 1, it goes up by 1 here, and it goes up by another 1 here. If I'm going to do the same thing on the y side, I notice that my y, each of them go up by 2, 2 to 4, 4 to 6. So let's graph that. Okay, so I'm going to go here, I'm going to start at 2, I'm going to start at 4, and go up to 4, and then go up to 6. Okay, and my graph's going to start at 0, 0. Okay, so how am I going to graph my data points? Well, I'm going to look at the relationship here. So x is 1, y is 2. I'm going to put a dot right there. Let's scribble that in a little more. Okay, now make sure it lines up with your grid paper. So if my grid would continue from here up and here across, then that point would be there. Okay. My next point I'm graphing is 2 and 4. So 2 and 4, that point will go here. And then my third point is at 3 and 6. Okay. So when you graph all of your data, this then becomes a scatter plot. Okay. To complete my scatter plot, or to complete my function, I have to realize I have a relationship going on in my graph. Okay, so the 1 and 2, 2 and 4, and 3 and 6, each of these are called ordered pairs, meaning that they're in order of x and y, and that they are paired, meaning that if x is equal to 1, y will always equal 2. Okay, I just picked this for example if I graph this on graph paper. Now when I connect my dots, I'm showing my relationship. Okay, so if I go to connect this graph, for example, I'm going to connect it right here through the line. This should go through 0 if I drew it correctly. Sorry. I get a nice linear function, a nice linear line. So in grade 9, we're trying to figure out what the equation of this line is. Okay. So how do we figure out the equation of the line? Well, we need to know what the equation could look like. Okay? So if I go here, we need to know y is equal to mx plus b. Now, you're going to see this a lot in your learning of mathematics from here on. Okay, so it's something you should be familiar with. This is the general equation of a line. Okay. Now, what does the y stand for, the m stand for, the x stand for, and the b stand for? Well, I'll tell you right away. Okay, the y is the y value on your graph. So it's a y value from an ordered pair. Oops, from ordered pair. Okay, the m is called the slope, which we'll talk about when I go back to my graph. Slope being the change in y over change in x, and I'll explain what that means. The x is the x value in the ordered pair you're looking at. Okay, so if x was 1, then y would equal 2 in our equation. And b is your y-intercept, where the line of the graph crosses your x-axis. So if I go back to my graph, I just redrew it to keep it more organized and neater. If I go back to my graph, I look at some values. So if I wanted to figure out the equation of the graph, I write my general equation. So I start off with y is equal to mx plus b. And then I pick an ordered pair. So I'm going to pick the 1, 2. Those are nice easy numbers to work with. Okay. And now I'm going to look at the graph if I could figure out b. Okay, so b is where my line, or my linear line, crosses the x-axis. So I picked this data for that reason. So my b here is equal to 0. Okay, another way to find out b is if you made x equal to 0. Because if there's a b and it's crossing the x-axis, then x won't have a value. So x will always be 0. Okay, so sometimes it's going to be 0, 0, but it depends. And I'll show you a question in a couple of minutes. So I can substitute my value of 0 into my general equation. So it simplifies down to y is equal to mx plus 0. Okay, now I need to find my slope, or my m. Okay, so slope is about rise over run, or change, which I showed the other day on the board. And it's the change in y, so how y changes from 2 to 4, and how x changes from 1 to 2. Okay, so there is a formula, but we're not going to learn it in grade 9, but if you want to, if you're interested. So it's the change. So we draw change in math with the triangle. Okay, change in y over change in x. So slope can be a fraction, so it depends on what the change looks like. Now if I go back to my graph and I want to change a different color. If I want to look at my change in y, well, I look y at 4, and if I go down to 2, what's the change here? Okay, well, it went from 2 to 4, so it went for a change of 2. Okay, then if I look at my change in x, it went from 1 to 2. So x only changed for one spot. Okay, and if you go through the graph, you can see that it's consistent, right? So if I go from 6 to 4, if I drop this down, that's again a change of 2. So it keeps repeating that pattern. Slope is a pattern. It'll always be the same, right? So if I go back to my initial equation and I want to write in slope, then I can write in y is equal to my change in y, which was 2, over my change in x, which was 1. And then don't forget your x plus 0. Okay, so that's what my equation looks like before I simplify it. When I simplify it, it just becomes y is equal to 2 over 1 can just be written as 2. Don't forget your x next to it. And I don't have to include the 0. So my simplified equation for this graph is y is equal to 2x, meaning that if I picked a random value for x, so if x was 4, I can use my equation to solve for the graph. Okay? So just to recap things you need to remember that x is your independent variable. It's always on your horizontal. Y is your dependent variable. It depends on x. It's always on your vertical axes. Remember to label your graph. So label what x is, label what y is, and give your graph a title explaining what it's about. Remember that slope is equal to the m. And remember that your general equation for any line is y is equal to mx plus b.